it's recording.
So I'll explain about BusterNet. Buster is like getting caught or making it caught. So what it does is it copy, move, forgery detection. So this paper is about copy, move, forgery detection. Basically a Photoshop detection. You have gone through this?
Yes, sir.
So what I exactly mean is, given an image, see there is a date of birth 28/01/21. So what I do is like I copy this to and place it here using Photoshop. So we have to localize this region plus this region. So this has been copied to this place. So the image will be like 2, 1. So we have to detect that this has been copied to this place. This type of forgery is called copy move. There is also one more as copy paste, where you just copy from a different image any feature or ROI and place it on a different image. Detecting this forgery is copy paste. Very few research has been there in this domain. Reasons is like one, it's like not easily doable, and one more is there is not lot of use cases. But for us, this is one of the main use cases. So previous work, a lot of people were trying to do with this image processing based approach. The pipeline is like given an image, extract features, compare features, whichever matches with certain threshold, that are the features, and the features corresponding to those RIs are the forge regions. This approach, this is a standard approach even in this paper also. But one new way is they have solved it with the deep learning approach. And I think this is one of the first papers which came to solve this problem. Just give me an example of how you do this.
How you do it?
How will you implement this flow in using CNN?
Your feature extraction will be CNN. Your ROI also you can translate the faster version setting up anchors or whatever.
Okay.
Single shot also you can just regress over the anchor.
But this part, how will you compare? You can directly pull to the desired, directly regress it to the desired coordinates, expecting it to learn the comparison features. But this part, how will you implement?
Here we are comparing more.
So it has to, it's like there is some feature, say this 2 in certain region. This feature should be the exact match of some other feature, not exact, at least 95% or 90% should match. So there is 2 features you have to compare.
Maybe
that is not there.
Maybe we can add an extra head of a feature similarity head. After the ROI, we can add a separate head.
After ROI coordinates, after you get the coordinates, you want to how
when you're doing sorry on the comparison step maybe um, there you're comparing features similarities between two separate features, right? So there maybe you can add extra um, like two fully connected networks maybe
fully connected network.
like small and do a feature comparison.
Like similar but not fully connected.
Two linear layers.
I did. So what the initial approach, the naive approach is, one is FRC, object detection. So you directly give the coordinates and regress it, and expect it to learn everything. That is one approach. Second is also segmentation. You can try pixel-based classification. Also you can do for the regions. But the challenge is these are very naive approaches. Why is the features will be how does it? You can easily extract the target. Target means the one where you copied from. This is target. This is source. Sorry. Sorry. This is source. This is target. So this is the target. Why I'm saying is target will have some distinguishing boundaries which can be easily formed, but source is very difficult to learn. And one more is features will be very small. Like the features you want is like very small. The thin edge boundary and the copy function. So people have tried this, but they are not able to reach good level of accuracies. Yeah. So I'll also tell one of the image processing approach. So so the this is a this approach is better than even the FRC and direct pixel-based classification approaches in one of the data. So what they do is they split the image into 16 cross 16 or 8 cross 8 so segments. So they then calculate the feature for each of this pixel. ROS. What feature they do is DCT, discrete cosine transformation. Once you calculate, you have a vector. Then you calculate, loop over all this and calculate for each. Then now this each DCT represents a unique footprint for this segment. What you do, you sort it all the segments, then you will get a sorted one big chunk of it. Like I think if it is like 16 to 50, then you do a 1:1 comparison, like correlation. So assuming that each next layer will be having the same features because it's sorted, so your computation will be less. That's the only thing. Then you try to calculate, then you give a certain threshold for each coefficient, and then you filter all the coefficients which are like less, and you if you plot the values back, you will get the exact mappings of the source and the target. This is clear. I think that was not clear. Okay. I'll explain that you will understand. just assume like you take patches and compare, calculate a feature and try to compare it each other feature in the image. That's what they do is like they have a CNN-based structure. They use VGG16. VGG16 and then they get 16 cross 16 cross 56. Similar to the one we got that. So they assume that each 16 cross 16 is a patch which represents a certain feature in the image, such that they have 256 features. What they do, now they calculate self correlation. Then um, this they have written a unique module. It's the same mathematical function but in a vector form. And once you get the correlations, again they sort it so that whichever has the highest correlations are at the beginning in the descending order. Then they pool it to a certain size, say called K size, K pool. So they take only the top K features and then they pass it to pixel-wise prediction. Same concept. So whatever highly correlated features are only taken for the subsequent in task. Or they do upsampling. I think what else you just to match this size, this input size. This is one of the approaches they tried. This they called as SimiNet. And they also do for both source and run. What they also did, they also developed one more. This is similarity network. One is manipulation network. The same without this self correlation and pooling, direct regression of only the target. So one network only calculates the target. And what they do in the end, they have a similarity net. And they have a manipulation network. Then they fuse the features together. They just concatenate it. And again, do upsampling for both. Then they do a pixel-wise segmentation. That's it. Fusion, instead of taking it, they remove these layers and fuse it for the appropriate size. That's it. Other than this, like publishing stories. Yeah,
No, sir. I have to go through them.
what else? I didn't explain it to you.
Loss is binary.
I understood this part properly. That I didn't.
This one. Same network. They have a what this is called bilinear network.
Bilinear network.
What this is called, like if you have two parallel networks.
Siamese.
Not Siamese. Siamese will have interconnected bits. This will not have.
Dual path.
Dual path. A same network, they just fuse the features together and do a prediction.
Okay.
Just to improve, boost the accuracy. But this is their main fund. Sorry, this pooling part, self-correlation part, they just take, they normalize all the features and then they do PSL correlations on the functions.
Yes.
Yes.
I also tried this for our type of forgery, but uh, one problem is we have very small features, that is text. So all this data sets they were using, they have a pretty dominant feature, and that dominant feature is copied to the next. There is something also called as mantra, which based on this they calculate the dominant feature and try to check whether the dominant feature is copied or not. That's it. But our case is like our features are text which is very small and which is in huge numbers, so it's challenging for us. Still solve. And I also tried this porting this to PyTorch, but I'm not able to train it properly. I'll cross verify TensorFlow again.
We make the implementation project.
I've already made.